Atoms of all elements are exactly the same, right? Well, not exactly. All atoms of a given element have the same number of protons and therefore the same atomic number. However, most elements have more than one isotope. Isotopes are atoms of an element that have the same number of protons, but different numbers of neutrons. That means they have the same atomic number, but different mass numbers. The chemical properties of the isotopes of a given element are essentially the same. For example, all atoms of hydrogen have one proton. Most hydrogen atoms on Earth have no neutrons. This isotope has an atomic number of 1 and a mass number of 1. It is called hydrogen 1. A small proportion of hydrogen atoms have a nucleus that consists of one proton and one neutron. This isotope has an atomic number of 1 and a mass number of 2. It is called deuterium, or hydrogen 2. Both these isotopes of hydrogen have the same atomic number, but they have different mass numbers. Deuterium has twice the mass of hydrogen 1. A third isotope of hydrogen, tritium, has 3 times the mass of hydrogen 1. How do scientists measure the small differences in the masses of isotopes in elements? They use a mass spectrometer, which separates vaporized ions according to their masses. It shows the relative masses of atoms. For the sake of convenience when working with atomic masses, chemists have decided on a standard unit, the atomic mass unit, AMU. 1 AMU is 1/12 the mass of a carbon-12 atom. That's a carbon atom with 6 protons and 6 neutrons in its nucleus. The atomic mass unit is useful for comparing the masses of different atoms. 1 atomic mass unit equals 1.6605 times 10 to the minus 24 gram. Don't worry about remembering this value. The main point is that the atomic mass unit is a measure of actual mass. Though most elements have multiple isotopes, each with a slightly different mass, only one mass appears in the periodic table. That mass is the relative atomic mass. It is a dimensionless quantity since it is defined as the average mass of the atoms of an element divided by 1 AMU. The relative atomic mass of an element is sometimes referred to as atomic weight, or just atomic mass. The average atomic mass of an element is the average of the atomic masses of each of an element's isotopes, weighted by natural abundance. It is measured in AMU. Let's look at how to calculate the average atomic mass of carbon. 98.89% of carbon on Earth is carbon-12, which has a mass of exactly 12 AMU. Another 1.11% is carbon-13, which has an atomic mass of 13.003 AMU. There is also a small amount of carbon-14, but it is too small to make a difference at this level of precision. That gives us an average atomic mass for carbon of 12.01 AMU.